Welcome students for this session of microcontroller. Today also we'll be studying on module 3 about ports, switch and LED, how to connect a switch and an LED to the port. Okay, we'll see that. We'll take first example where a switch is connected to pin P1.7. Write a program to check the status of switch and perform the following. So you need to check the status of the switch. If the switch is 0, send N to P2. If switch is 1, send Y to P2. This is what we need to do. So where is the switch connected? Switch is connected to P1.7 and you need to send the data to P2. So that is what is the requirement. Understand the program first to write a requirement of the program first to write the program, right? So we'll see how to write a program. So let us make P1.7 as 1 because for any port pin, if it has to work as an input port, it should be high at initially, right? So the value of P1.7 bit is made as 1 in order to make that pin as input port. Fine, then what is that we'll be doing? Check that pin if the pin is 1 or 0, right? So this is what is the switch which is there at P1.7. Check the pin which is P1.7 and if it is 1, right? JB is the instruction. Jump if the bit is set. Jump if bit set, which bit? P1.7 is the bit. If this bit is set, then I need to jump to a location which is over. Over is here. So what is that I need to do? If the bit is 1, that is switch is 1, I need to move what? Y to P2. So this is what is move P2 comma hash Y, where we have enclosed Y in a single quote. That is the ASCII value of Y will be moved to P2. If not, that is if your P1.7 that the switch is 0, then it will not jump to over. It comes to the next instruction which is this, which is move P2 comma hash N. So here I'll be moving the ASCII value of N to P2 and then I'll repeat this for N number of times. So this is what is my program where we check the status of the port pin P1.7 which is connected to a switch, and if this bit or the switch is 0, then we'll be sending N. If not, we'll be sending Y. We'll go for the next example. A switch is connected to pin P1.7. Write a program to check the status of switch and perform the following. So what is the change from the previous program to this program is, here we are supposed to use carry flag to check the switch status. So instead there we use the instruction which was JB, that is jump if the bit is set, right? So that is what we had used. Instead of that, here we'll be using JC. So what is JC? Jump if carry bit is set. So what is the change? What are the changes we have done? So the changes here is, after we have made the port pin P1.7 as the input port, we will store that status of that in a carry flag. We'll move that value of P1.7, either it is 1 or 0. We copy that value to move to carry flag and we check the carry flag. So status of the switch is checked using the carry flag here. If carry flag is 1, we go to over, where we will be moving Y to P2. If carry flag is 0, then we will move N to P2. That is, we will be checking for the carry flag and then do the same procedure whatever we have done. So only changes, instead of using JB, we are using JC. One change. The other changes, as we are supposed to check the carry flag, we need to copy the value of port pin P1.7 where the switch is connected to carry flag. So these are the two changes. You have to note what all are required and then write the program according to that. Right. Next, we'll go for the next program where a switch is connected to pin P1.0 and an LED to pin P2.7. We have connected a LED and a switch, right? Switch is connected to P1.0 and LED is connected to P2.7. And what is the program requirement? Write a program to get the status of the switch and send it to the LED. what I need to do, I need to check the status of the switch, and based on that I need to send the status to LED. So what is that I am doing? I am making P1.0 as the input port because this is a switch pin. I'm making it as an input pin, and when I get the status here, move P1.0 to carry flag. So I need to just send the status. So whenever the switch is pressed, it becomes 1. That is copied to carry flag. Again, move that carry flag to P2.7 where your LED is connected. And this I need to do repeatedly. S jump is short jump to a location which is again, and I'll be jumping to this location, and I'll be repeating these two instructions for a n number of times, where I'll be just checking the status of the switch and I'll be moving the status to LED. So this is again a program where we are checking the status of switch and moving the status to LED. In the previous two examples, we checked the status of the switch and we had moved N or Y based on the status. In this case, in this example, we are checking the switch and we are moving it to LED connected. This is one of the questions from VTU. Let me read out the question. Write an ELP to read switch given in the figure. This is the figure given. If the switch is closed, turn on the LED, else turn off the LED. So there is a switch here. If the switch is closed, I need to turn on the LED. If the switch is open, then I need to turn off the LED. So that is what is the requirement of the program. So how to write this program? Let me start with org0h. That is, I am originating. I am starting from 0th location. I'll be making P1.1 as my input port. Hence, it will be, I have written a comment also. What is that I need to do? I need to check the switch status. So JNB P1.1 is, I'm checking the switch status. If it is not pressed, that is, I need to go to clear, where clear is a location where I am clearing the bit P1.2. Why I am clearing it? If I send 0, then only my LED will be turned off. And then what is the other thing, other status? If JNB, that is JNB here is jump if not bit set, right? Correct? If the bit is not set, which bit? P1.1 is not set, I'll be moving to clear. If it is set, which bit? P1.1 bit is set, then I'll be moving to the immediate next instruction, which is set bit P1.2. So here I'll be setting the bit P1.2, or instead what is that I am doing? I am glowing the LED. My LED will glow here, and then I'll say S jump again. I'll be repeating this set of instructions for a number of times. So what did we do in the program? We are checking the status of the switch. Based on the status of the switch, we are glowing, or we are switching off or on the LED which is connected, right? So we first make the port pin P1.1 as an input port. Check the status. If the bit is 0, we need to turn off the LED. If the bit is not 0, that is, if the bit is 1, switch bit is 1, then I need to turn on the LED. So this is what is the requirement of the program. So this, after learning this, what is that we'll do is, let us take this example, execute in a KEIL, and then work out whether I'll be able to do the same or not. So I've copied the program here. So I'll repeat the procedure, whatever we have done. I hope you all already know, but still I'll be repeating the program. Let us go to project, new project, right? Click on the project, and in that new project, whenever you get a new project, give a name for the project. The name of the project, let me give the name of the project as LED and switch. LED switch is the name of my project. Save the project. When I save the project, I'll be getting a option to select the chip. I'm using Atmel, so I have selected Atmel, and we are using Atmel 89C51. So say OK for that. When I say OK, then I'll be generating my project here. You can see the left side, there's a project window which is being created and you have a source group created here. Next is go to file and you can say new. This is one thing, right, where you'll be opening your editor window and you'll have to type your program. So I have typed the program here, where the program is to switch on the LED based on the status of the switch which is being connected, right? So I'll just save the program. I'll give the name of the program with an extension. Yes, because this is a assembly language program, so I'll have to save it. I'll be saving it as switch LED assembly, right? We are using assembly program. I'll just give it as assembly program dot some name with an extension. S is very much required. Save the program, right? Once you have saved the program, add that program to your project, right? So how to add it? Right click on the source group 1, then go to add files to group source group 1. You need to click on this. When you click on that, you'll be getting an option to add. A list of options will be provided. Here in the drop down this thing, you just select arm source file .s. .s is the extension. So you'll be getting the search in this, which is your program. So we have given it as switch, right? Switch LED assembly language, right? So this is my program. Select it, add it, and then close. When you do that, you can see that in the left side, the source group is created and your file is added here. That is switch LED assembly language program is added. Now what is the next procedure? You need to save the program, then go for translate. This is the icon for translating, where your program gets translates and give you if you have any errors and all, right? So I don't have any error. Next I'll go for build. So I'll build my program with, I want to build it with the libraries and all. Then I'll go for build all option. So once this procedure is complete, you should remember that you should get it as a 0 warnings, right? If you don't get it as a 0 and 0 errors or 0 warnings, there are some errors in the program, right? Once you have done that, now go for debug. Let me tell you one more option, one more point to remember is, now this I want to show the demonstration on PROTEUS software. So if I want to use PROTEUS, then I need to dump my program, which is a hex program. Hex file should be generated. So you can see that we have not generated any hex file. To generate a hex file, what is the procedure? Right click on target one. Here in the left side we have target one. Right click on the target file. There options for target one is given, right? So click on that. There, if you click on that, then you'll be getting target. I want to change my crystal frequency. I'll be changing it to 12 megahertz, or you can even write 11.0592 megahertz also. Let me use 12 megahertz. Then I'll go for output. This is at the target. Then if I click on output, I'll be having this option, check this option, right? There's a box to check this, create hex file. I am trying to create a hex file, hence you can say this, right? So say okay. When you say that, see in the build output, this menu, build output window, you can see that hex file is not created, right? So what is that? After I have checked the create hex file, I need to translate and build the program again. So if I do that, if I am doing now build, you can see that creating hex file in this window, build output window, we are seeing that your hex file is created. That is, the hex file name is LED switch. What is that? You can see we are creating a hex file, and the name of the hex file is see, creating hex file from LED switch. This is the name of the hex file which is created. Now what is that I'll be doing? The one which we saw is from the KEIL software, right? What is that I'll do? I'll go to before going for KEIL, before going for PROTEUS, we'll see the debug version, what is happening in the debug, right? Let us debug the program. So go to the menu bar and click on this D. So this is what is the debug, right? When you enter into debug mode, then you have to select the port. I want to check ports P1.1 and P1.2. So go to peripherals in the menu bar and then click IO port 0. In that I'll be selecting port 1. Select port 1 and when you say run, you can see that initially, right, this is not set. When I say 1 here, that is a switch bit which is connected at P1.1. I'll just click on this. So you can see that even P1.2 is getting on. That is, switch is on, here LED is on. Switch is off, LED is off. You can see that, right? I'm clicking on P1.1 where my switch is connected. If it is on, P1.2 is also on. When I click this, I'll share you people with the PROTEUS screen where I'll be sharing this with the PROTEUS. Let us see what is happening in the PROTEUS, right? You can see that this is my PROTEUS window where I have already created one project based on the previous example. Let us run and see this. How does it work? If I press the switch, I'll be pressing the switch. If I press the switch, LED is on. Just see that pressing the switch, LED is on. So now how to do this, right? So let us learn the procedure in the PROTEUS also. So I'll be opening a new schematic window where schematic capture. I'll tell you the procedure for this also, right? So let us open a new PROTEUS capture window where I'll be saying, see here, this is the starting menu. When you click on the PROTEUS, here you on the menu bar you have schematic capture, right? You can see that on the menu bar you have your schematic capture. Click on that. When you click on that, a new schematic window opens. This is my schematic window where you have your P is to place your parts. So click on place parts where I will be adding my Atmos 89C51, right? I am selecting 89C51. This is my chip which I want to use. So double click on that. When you double click, it gets added here, right? What else I want? I want an LED. Let me take an LED which I want. Let me take it as a yellow color, right? This with the yellow. So I have selected this. See, this is LED yellow. Double click on that. That gets added to your library. Next is again I want a button or a switch. So for that, I'll be using button, right? So I'll be selecting this button, button. If I say type here, I'll be getting the button. I'll be using this button. You can see the right side, the diagram of the button, right? Double click on that. Once you've added all the three from the library, right? Say OK. When you say OK, you have the overall what all the components we want for this project, right? So click on now Atmos 89C51. This is the IC. Where will I place, right? So if you click on that, you will have the IC. I have placed it here, right? I'll be taking the button, right? That's the switch. I'll be placing the switch here. So I'll just place the switch here. Then I'll take my LED. LED, I'll place it here, right? So I have placed it here. Now I need to do the connections. To know the connections, to do the connections, we are not able to see the port pins, right? So we need to zoom it out. How to zoom out? Scroll your cursor so that you'll be getting a zoomed out screen, right? So this is your zoomed out screen where if you place your cursor, this is a cursor, right? Cursor point at your switch point, you get a red dot, right? Connect that to the port pin P1.1, right? We know that a switch is connected to P1.1, right? I have connecting it to P1.1. I have connected that to P1.1. Next is I have to connect. Let me connect once again. right? So I have connected the switch to P1.1 and LED I'll connect it to P1.2. I have connected the LED to P1.2. We should also connect ground and power. So to connect ground and power, we will be using this on the left. We have here terminal mode, right? Click on the terminal mode, right? When you click on the terminal mode, you have power and ground. Can you see that, right? So this is my power and ground. I'll be taking the power button and I'll be connecting it to the switch here. So place the power button, connect it to the switch, right? Take the ground and then place it here so that we will be completing the circuit, right? So this is the circuit is completed. So connected. So once you have connected, your circuit is complete. You can see that your circuit has completely connected, right? Now connection is complete. What is that I need to do? I need to load my hex file onto the microchip, right? Microcontroller chip. So on this, double click on this microcontroller chip. Here you have to open program file, open, right? You should remember that your program is there with the you should remember what name you have given, right? So our program is with led switch dot hex. So I'll be loading that program to my chip. Say okay, why did I make that 12 megahertz is, see, you can see that here my operating frequency of the microcontroller is 12 megahertz. So I have given it as 12 megahertz even in the KEIL also, right? Then say okay. When I say okay, my connection and dumping of the program is ready, then I'll say run. When I say run, right, it is running. Now click the button. How to say run? At the down here, you have a run symbol here, right? So this is the symbol for running. So run, click on that. It will be in a run mode. Then switch is pressed, LED glows. Switch is pressed, LED glows. Then you can stop the program again by clicking here. This is to stop. Now this is how, now when you click it, it will not work because it's not in execution mode. Again, you want to check how to run. Go to this run at the down left. You have run. Click on that, and then again, if you click on your switch, your LED glows. When you release, your LED is off. Switch on the press on the switch, LED glows. Release it, it will be off. So this is what is the program for LED glowing. So we have seen the demonstration over KEIL and also we have seen the demonstration with the PROTEUS software. Try for yourself. This is it for today. Thank you.